Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, Senior 3 Chemistry class. You are most welcome for today's lesson. I'm Chaskovia, your chemistry teacher, as always. So we are here to continue with Unit 2, which is nitrogen and its inorganic compounds, right? We have been, in the previous lesson, we have been looking at some of the inorganic compounds of nitrogen. We had looked at nitrogen dioxide. We looked at its preparations. We looked at its properties, its uses, all right? So we looked also at ammonia as another inorganic compound of nitrogen. So we are continuing to look at other inorganic compounds of nitrogen. So today here we are going to start with, to look at another inorganic compound of nitrogen, which is nitric acid. All right? We're going to look at nitric acid. So what are we going to put emphasis? We're going to look at its preparation, the preparation of nitric acid, the properties of nitric acid, and uses of nitric acid. All right? That is our emphasis today. So what is the objective? What is the objective of the lesson? The objective of the lesson is to describe the laboratory preparation of nitric acid, the properties of nitric acid, and we state the uses of nitric acid. Right? Are you ready? So get your book, get your pen, and we start with the lesson. I think you're ready. All right? So we can start off. First of all, we said we are going to look at the laboratory preparation of nitric acid. Right? Laboratory preparation of nitric acid. The laboratory preparation of nitric acid. So that is the diagram. That is the diagram for the laboratory preparation of nitric acid. So I told you, when we are looking at the laboratory preparation of nitric acid, we put emphasis, whenever we are talking about preparations, we put emphasis on the diagrams. You need to know the setup of the diagram, all right? You need to know the equation of the reaction. What are the reagents? What are the reagents? For this case, therefore, in the laboratory preparation of ammonia, of nitric acid, laboratory preparation of nitric acid. I told you there are things you need to be knowing, or you need to know. First of all, you need to know the reagents. The reagents. For this case, the reagents we have concentrated sulfuric acid, excuse me, and potassium nitrate. All right? Concentrated sulfuric acid and potassium nitrate. These are the reagents we have. All right? So the equation now, the apparatuses, we have the retort stand, as you can see, the apparatuses on the slide. On the slide, we have the retort stand to hold the retort glass bottle. We have the clamp, all right? We have the round bottom of the flask. We have the tap water to cool the gas. This is the clamp to hold the glass, the round bottom of the flask. All right? Those are the apparatuses. Now, you should also be having the heat source. There should be supply of heat. All right? So the equation now. You need to know the equation. I told you this is very important. The equation of reaction. So when potassium nitrate, it is solid, reacts with concentrated, when it reacts with concentrated sulfuric acid, how do you know this is concentrated in an equation? I told you this. When it is concentrated, we put L. We indicate it as a liquid. But if it was dilute acid, it would be aqueous. All right? So whenever you see there is L here, you get to know it is concentrated sulfuric acid or any other acid with L here. A state which is L, which is liquid, it indicates the acid is concentrated. All right? Good. So when we react potassium nitrate with concentrated sulfuric acid, we get potassium hydrogen sulfate plus nitric acid. Potassium hydrogen sulfate, but this is aqueous then, plus nitric acid, which is also aqueous. So you remember in writing equation, I told you there are things you need to put into consideration. One, you need to write well the symbols. Don't write small o, don't write small n, don't write these two on top, just put them the one. They are supposed to be written. Another thing you need to take care of is to write the states of matter, to indicate the state in which the reagent or the substance exists. Solid state, liquid state, aqueous, aqueous. Another third thing which is also very important that you need to put into consideration when you're writing a good chemical equation is to see if the equation is balanced. We can pass through it and see if it is balanced. We have potassium 1, potassium 1. You look at the reactants and the products. We have nitrogen 1, have 1 nitrogen also here, right? We have oxygen 3, we have 4, these are 7 oxygen. How many are here? We have 4 and 3, those are also 7 oxygen. Hydrogen, there are 2 here. Hydrogen, have 1 hydrogen here, another hydrogen here, making 2 hydrogens. We have sulfur, we are remaining with sulfur. Have 1 sulfur here, have another sulfur here. So the equation is balanced. All right? So this is a well-written equation. So in preparation of nitric acid, we need the reagents. These are potassium nitrate and concentrated sulfuric acid. When they react, they give off, they form potassium hydrogen sulfate, and nitric acid. All right? So this is go back and check the apparatuses on the slide. Check the apparatus on the slide. You see? There is normally, in fact, nitric acid is colorless. The reason why you see it is a kind of red-brown color is because there are some nitrogen dioxide produced there, right? So this is nitric acid. It is condensed by this tap water, then collected as nitric acid, all right? So the nitric acid collected in this is red-brown, as I've said, because it contains some dissolved nitrogen dioxide. Otherwise, the pure nitric acid is colorless. I mentioned that. So if you look at here, you can see that this nitric acid is red-brown, is a bit brown. But that is not the real color of nitric acid. It's because there are some dissolved nitrogen dioxide, and nitrogen dioxide, remember, it has got a brown color, a red-brown color. So that's the one that gives the color of nitric acid to become, or that gas to become red-brown vapor, because there are some dissolved nitrogen dioxide. So the pure nitric acid is formed when it is bubbled, removed by bubbling air through the acid. All right? You note that nitric acid is kept in a darker bottle. Always and always in the laboratories, nitric acid is kept in dark bottles. The reason being that when light gets into contact with nitric acid, it decomposes to give out water, nitrogen dioxide, and oxygen. Get that? So always you will be seeing nitric acid kept in darker bottles. In an exam, you can be asked that. Why is it that always nitric acid is kept in darker bottles? Nitric acid is always kept in dark bottles, being that if it gets contact with light, it decomposes to give out water, nitrogen dioxide, and oxygen gas. All right? So that one is, it can't be kept in the light bottle or in the glasses, open glasses, because when it gets contact with light, it decomposes to give out nitrogen dioxide, oxygen gas, and water. That is something to note. So we can also manufacture nitric acid by using what we call Oswald process. So how does it work? This is just the catalytic oxidation of ammonia. We go on oxidizing ammonia, and then finally we get nitric acid. The catalytic oxidation of ammonia. That is Oswald process. You remember in the previous lesson when we were studying about ammonia, we said ammonia is used in manufacture of nitric acid in Oswald process. That's where it comes in. So in Oswald process, when we are manufacturing nitric acid, there is oxidation of ammonia. So what do we need to be having? We need to be having the raw materials. What are those raw materials? Ammonia, air, and water. But there are conditions to follow. There should be a temperature between 850 degrees Celsius to 900 degrees Celsius. This is a very high temperature. And we need to be having a catalyst which is platinum or radium, any of the two. Platinum or radium can be used as a catalyst. What is the role of a catalyst class? In other words, what a catalyst is. A catalyst, you remember, it is a substance that speeds up a reaction and remains unchanged at the end of the reaction. It just speeds up the reaction. A reaction that could take place in 5 minutes just takes place like around 2 minutes. So it speeds up the reaction. That is a catalyst. So for the case of the Oswald process, we can use platinum or radium as catalysts. So what are the reactions that take place? Here we have around 3 to 4 reactions that takes place under oxidation, catalytic oxidation of ammonia. One, the first reaction is to oxidize ammonia, you get nitrogen dioxide and steam or water. So the nitrogen dioxide that you have got is also oxidized to get nitrogen dioxide. Right? That is the second step. So the nitrogen dioxide, third thing, the nitrogen dioxide, you add water. Remember in the raw materials we have water. You add water, you got nitrous acid and nitric acid. Nitrous acid and nitric acid. So the excess air is passed also to oxidized nitrous acid to nitric acid so that you get abundance of nitric acid. That is what we call the Oswald process, or what we call catalytic oxidation of ammonia. You have around 4 equations there. The first equation is to oxidize ammonia, and you get nitrogen monoxide plus steam or water. The second step, the nitrogen monoxide you have got, you add or you oxidize it to get nitrogen dioxide. You add more oxygen. You remember in the raw materials we have, oxygen is there, air is there. The air we are talking about is oxygen. So we have oxygen there. So then the next one is to add water. When you add water, you get nitrous acid. Nitrous, when it has 2, we call it nitrous. When it has 3, we call it nitric. All right? So finally, even this nitrous acid, when you add excess of oxygen, it is turned to nitric acid. So you can look at the diagram there, the Oswald process. That is the diagram we have here. You see, I have this compressor. There is platinum as a catalyst. So you have the volume of ammonia, some ammonia and oxygen entering into a converter. It is oxidized to nitrogen dioxide and steam, you remember. So the nitrogen dioxide meets with, it goes in oxidation chamber to more oxygen to be added and forms nitrogen dioxide. So the nitrogen dioxide is added with water. You remember we get nitrous acid and nitric acid, but more of oxygen is added, or oxygen is added in excess, even the nitrous acid to be converted into nitric acid. So it is collected here. Absorption tower. This is absorption tower. So you put a tank somewhere here and you collect the nitric acid you have prepared here. This one gives around 60% pure of nitric acid. However, the purity of the acid can be increased by distillation. So if you want this acid to become pure, it can be made pure by distillation. All right? I think this is clear. So you need to know in a Oswald process, we just deal with catalytic oxidation of ammonia. You need to know the raw materials. You need to know the conditions, temperature. All right? You need to know even that when at the end when you form nitrous acid and nitric acid, excess of oxygen can be added to convert even the nitrous acid into nitric acid. So the unreacted ammonia and nitrogen dioxide are recycled, all right, back into a compressor to do what? To react again, to be made, to be oxidized again so that they can form enough nitric acid. We just don't leave it like a waste product. All right? So the unreacted ammonia and the nitrogen dioxide are recycled. All right? I think that is clear to you. Good. So those are two ways on how we can manufacture or we can get nitric acid. One we talked of the laboratory preparation, which is the reaction between potassium nitrate and concentrated sulfuric acid to get potassium hydrogen sulfate and nitric acid. Then the other one is Oswald process, where there is catalytic oxidation of ammonia. Good. So we continue with the chemical properties of nitric acid. The chemical properties of nitric acid. Right? Under this, we look at how nitric acid reacts with carbonates, hydroxides, and some oxides. Right? How does nitric acid react with carbonates, react with hydroxides, reacts with oxides. Briefly, when nitric acid reacts with metal carbonates, you have to put that into considerations, and hydrogen carbonates, it forms salt, water, and carbon dioxide gas. I repeat this. When nitric acid reacts with metal carbonates, it forms O-stroke hydrogen carbonates. It forms salt, water, and carbon dioxide. Salt, water, plus carbon dioxide. For example, you get any metal carbonate, get calcium carbonate, plus nitric acid. From the slide there you can see. From the slide we have chosen calcium carbonate. Any metal carbonate, can be sodium carbonate, can be magnesium carbonate, any metal carbonate. Plus nitric acid, you get its corresponding nitrate, salt, that is calcium nitrate, because we have used calcium carbonate. Calcium nitrate plus water plus carbon dioxide. This is a salt I'm talking about. All right? Good. So when you react hydroxides, you form salt and water. Nitric acid plus hydroxides, you get salt plus water only. And we call this one neutralization reaction. This is neutralized like any other mineral acid, sulfuric acid, hydrochloric acid. This is not neutralization reaction. It forms salt and water only. Right? An example, you can get sodium hydroxide on the slide. Any hydroxide. Sodium hydroxide can be calcium hydroxide, magnesium hydroxide, aluminum, any hydroxide. Plus nitric acid, you got salt, that is sodium nitrate, because we use the sodium, plus water. Neutralization reaction. All right? Good. So how about oxides? So any metal oxide plus dilute nitric acid, you get metal nitrate plus water. Get an example of copper oxide. Plus nitric acid, you get copper nitrate plus water. So any metal oxide, it will form salt and water. That's how the chemical property of dilute nitric acid behaves. So reaction of nitric acid with iron, concentrated nitric acid with iron. So when a nitric acid oxidizes iron 2 to iron 3, you have plus 2 here to plus 3. We call it oxidation. There's an addition of electron. All right? So with copper metal, when copper metal reacts with nitric acid, we get copper nitrate plus water plus nitrogen dioxide. Then with sulfur, when nitric acid reacts with sulfur, it gets sulfuric acid, water, and nitrogen dioxide. So you need to know these equations, you need to know how to write them properly, and you need to know how to balance them and to indicate the states of reaction. Right? Good. So what are the uses of nitric acid? The last thing we have to look at the uses of nitric acid. One, nitric acid is used in nitrous fertilizers such as sodium nitrate, potassium nitrate, ammonium nitrate, calcium, and ammonium nitrates. All right? So it is used as a fertilizer in fertilizers. It is used in explosive like in trinitrotoluene, TNT, and dynamite. So it is used in explosives. In the manufacture of dyes, nitric acid is used. Then in manufacture of plastics, it is also used as an oxidizing agent in textile industries. All right? Also use nitric acid in refining of gemstones. So in the refining of gemstones, there is this nitric acid is very important. So I think you have picked or you have understood well the laboratory preparation of nitric acid, the Oswald process of manufacturing nitric acid, the properties of nitric acid, chemical properties of nitric acid. You need to know those equations and how to balance them and write their states and symbols correctly. Then the uses of nitric acid. So from there, you can try this question out. I leave you with a small work. You try it out. By the time we come back, we shall look through it and we'll see, because it contains all the majority of what we have talked about here. So there are around 4 numbers. In your free time, you try to work them out. Then we shall pass through them in the next lesson. So thank you so much for your good attention. Next time, bye.